Hey there, welcome back. I'm Adarsh, and as we'd mentioned in the previous part, in this video, we're gonna unravel the nitty-gritty of VR hardware and software. Stick around, because you're about to become a VR expert yourself. At its core, a VR headset is a mini computer strapped to your face, right? And as we discussed in the last video, the next step to immersion after 3D movies, after stereoscopic videos, is obviously virtual reality. So this means, yeah, you'll need to see things in 3D, but here, instead of showing you two images on top of each other, as they do in 3D movies these days, those two things that are being shown are shown separately to you. And that's exactly why there are two different high-resolution screens for your eyes to create that stereoscopic 3D effect. So what's a stereoscopic 3D effect? That was exactly what was covered in the previous video, so make sure to check it out. And to be able to see what is around you, there should be something or the other to actually show you, right? So to do exactly this, you can either shoot videos in 360 degrees and play it inside your headset using, let's say, a camera such as your Insta360, or just like how there are live action movies and there are animated movies, there are also games and movies that need to be artificially created on computers. And these games can actually be ported to VR headsets. But question here, for games on mobile phones, we actually have joystick pads on the screen to actually show the phone where we want the player to see, but how does it actually happen on a VR headset? That's where the years of evolution has actually led us to bringing sensors to actually track our movements and positions to make the virtual environments move according to our head movements. We have our accelerometer and gyroscope, and sometimes magnetometer, but more often than not these days this is actually achieved using external cameras. Gyroscope and accelerometers are actually used to detect your orientation and direction of rotation. So that actually lets us move our heads up and down, left and right, and side to side, right? And that's exactly where I want to introduce the concept of degrees of freedom. So when most people refer to this, most people talk about two types of degrees of freedom, or DOFs, which is 3 DOF or 6 DOF. 3 degrees of freedom meaning pitch, yaw and roll. Basically meaning movements in your 3 axes of motion. As I just mentioned, pitch is up and down, yaw is turning your head left and right, and roll is tilting your head side to side. And here, adding 3 more degrees of freedom means nothing more than just being able to move in this 3-dimensional space than just rotating your head around. Having 3 degrees of freedom means you can actually move freely in odd directions in the virtual space, making the experience much more immersive and interactive. So we have seen that until now, to reach 3 DOF, we have been using gyroscope on your accelerometer, which helps detect rotation. But to reach those extra 3 degrees of freedom, all the tech companies have been doing pretty cool stuff until now. Let's talk about it. So think about this. How does the camera, or let's say the LiDAR sensor in some of the phones, actually detect that I'm, let's say, in front of the camera here, or rather on the side of the room, or in, let's say, another corner of the room? To actually know that there are rays being sent out of the camera to actually capture me and take those waves back into the camera to process the image that you are seeing right now, isn't it? So to actually do this exact thing, we move one step further from your RGB cameras to your infrared cameras and make these into 2 different devices called base stations. So what actually happens is really interesting. So these 2 base stations that I'm talking about are placed at 2 corners of the room diagonally, and they actually form a sort of a grid around you. And since the rays are being sent in real time to know what is happening inside this space, and since the VR headset is able to recognize those signals and send back signals to these base stations, your exact location in real time can be detected using these base stations within this room. Another way in which these extra 3 degrees of freedoms have been achieved is by using computer vision or your machine learning. Basically nothing but the cameras in front of your eyes actually capturing all your image in real time, and you moving your head around actually shows different dimensions of your objects in real time again. And by detecting what objects move by how much, the camera is able to send to the processor what it's seeing, and the processor is able to say where you are in real time by stitching all these different images together in real time and processing it. Really interesting, right? So as you may understand, all this complex tech needs to also function within a compact space, and this is exactly why companies have turned to an OS that's already been getting prepared and buffed up to do exactly that, your Android OS. So with all this cool technology at our disposal, and with Android, our most familiar OS at this point, functioning inside this hardware, why don't we just make regular mobile apps work on the VR headset. This is where there's a little bit of a complication. At a deeper software level, after retaining the core of the OS, developers have actually changed Android in such a way that in its very core, it actually goes through the sensor and then renders to the two screens. And the UI that you're being shown is actually being rendered in real time as a 3D environment instead of your phone's regular home screen. So yeah, as you can imagine, you can definitely transfer any APK file over to the headset and even install it. Ana nahi chalega. So given that these games are actually made for virtual reality headset but built for Android, and in a tricky position where it can't really function on an Android phone but only functions for the VR headset, how does one actually develop for the VR headset? That's exactly what we'll look at in the next video. So, paklam.